class, welcome back. I hope you enjoyed your quick timeout. What I want to do next is talk a little bit about how to graph or how to make data visualizations in R. Now, data visualization is one of the most fun parts of the class, I think, because you get to actually see what's happening. The function or the tool that we're going to use to help us do data visualizations in R is something called ggplot. Now, this ggplot function comes from the tidyverse library, and to be perfectly honest, this is an incredibly versatile, incredibly popular set of data visualization tools. Very, very often when you are looking through news articles, posts online, data visualizations are probably created using ggplot. So here's how it works. First, what we do is take a data set and we send it into this ggplot function, either through a pipe or by just using the data argument within this function. What we want to do next is define what are called the plot aesthetics. The aesthetics of a plot are the things that are changing, the variables within the plot. So for example, what goes on the x-axis should be an aesthetic. What goes on the y-axis is one of the plot's aesthetics. We'll use AES for those. Any plot options you want to change related to a variable, these could be axes, these could be colors, these could be size of points, will be done within an aesthetic. Anything that you want to change that isn't related to a variable will be done outside of the aesthetic. So that's how this works. So let's just start with some examples and build a couple plots. So the first plot we'll build is pretty boring. So let's take the ICU admissions data set and just pipe it into the ggplot function. I want to plot this type, so the admission type, whether it was elective or emergency. Turns out this ggplot function on its own doesn't do anything. What we've done here on the right is just defined the plotting area. So we've built a gray box with type on the x-axis. There are two kinds of type, elective and emergency. If we want to go a little bit further and add more things to our plot, which we probably do, we'll use the plus sign to add elements. For example, we can use the geom bar. Geom understands for geometry, so the shape of our plot, to create a bar chart. So now what we've done is simply add bars related to the number of observations. We might want to make this a little bit flashier, so say we might want to change the fill or the shading of these bars. It depends on the variable, elective versus emergency, so we'll put that within a plot aesthetic. So these 3 lines of code create this beautiful bar chart. We can do things like add labels, so maybe we want to make the axis labels a little bit flashier. Maybe we want X to say admission type, Y to be number of patients, so we'll stick that in a labs argument. And there we go. We have a beautiful plot. As we get more comfortable working with R this semester, we will explore more customization options. So more colors, more types of graphs. But for now, we'll start fairly simple. So the next type of data visualization that I want to go over is something called a histogram. A histogram is a lot like a bar chart, but for a numerical variable. Here's how we build these. So we take the range of our numerical variable and we're going to chop it up or split it up into what are called bins. These are sub-ranges of equal width. We'll count up how many observations fall into each bin, and then simply draw a bar for each bin, where the height corresponds to the number of observations. The only thing that we need to change here, compared to how we structured our previous plot, was the geometry. So now I'm going to feed in a numerical variable, x equals age. To create a histogram, we'll use the histogram geometry, so geom underscore histogram. This argument inside the function, this bins argument, that simply tells R how many bars to split our data up into, or how many sub-chunks to group our observations into. So describing the distribution of age, the higher the bar, the more patients in the subcategory. So there are a lot of ICU patients between the age of, say, 50 and 75 to about 80. There's another peak in this data somewhere around 16 to 20. Most patients admitted to the ICU are over 50. If we remove that bins option, you can see that our plot changes slightly. The default here is 30 bins, 30 subbars, but we can change it with that bins option. Now, when we're looking at a histogram, here are the things that we might want to consider. We might care about the shape. So where's the typical observation? Where's the center of our histogram? We might look at the shape. Is it unimodal? Does it have one peak? Does it have multiple peaks? Is it symmetric, etc.? We'll look at the spread, so how spread out are the observations, and then we'll also look for outliers or unusual observations. So as an example, here are some common shapes that we might see in a histogram. On the upper left here, you have an example of a bimodal histogram. We have two major peaks on the data, one on the right, one on the left. We might also look at a data set like this upper right one. This is a pretty common shape too. This is a skewed right data set. So we have a major concentration of data on the left of the plot, and then things sort of trail out as we move to the right of the plot. The mirror image of this would be a skewed left plot. Think of where the tail or where the trailing off of the plot is. That's the direction of the skew. We can also see plots that are fairly symmetric or plots that are fairly uniform, like this purple one here on the lower right. It's fairly flat. There's not a lot of consistent shape to it. Now let's talk a little bit about what that outlier represents. So in a data set, an outlier is an observation well outside the typical or the usual range of values. So a point that is relatively large compared to the rest, or a point that is relatively small compared to the rest. There are tests and rules of thumb available to you for identifying outliers, but usually these stick out. You know them if you see them. For example, if we look at the heart rate of patients admitted to the ICU, there is one patient here on the very right-hand side with a heart rate much higher, nearly 200. Compared to the others, this is very much an atypical heart rate. One thing to point out here, for readability's sake, I have changed the shading of our histogram. So the fill, everything's colored in blue. The color represents the outline with a black outline. I'll do this fairly frequently just so we can see the bars a little bit clearer. The next type of plot that I want to look at is something called a box plot, and you've likely seen these before. You may have called them box and whisker plots in a previous class. In these box plots, there are a couple things that we'll want to look for. So here's what they look like. Let's talk about what we're seeing. The thick line in the middle of the box plot is going to represent the median. So that's going to be the middle observation for our variable. The lower end will represent the first quartile. The upper end will represent the third quartile. We'll talk about these soon. The whiskers in a box and whisker plot extend to one of two things. They extend to either the minimum or maximum, or if there are outliers, they extend to the last point that is not considered an outlier. Those dots on the outside of the box plot would represent an outlier. So let's start with an example. Is there a relationship between a patient's age and how they are admitted to the ICU? Well, let's find out. We'd like to write 2 or 3 sentences describing the distribution of patient age. So here's our data set. We now have 2 aesthetics. On the x-axis, we have admission type. On the y-axis, we have age. We're adding then a box plot on top of this plotting area where the shading of the boxes depends on the type. So that's what we're seeing here. On the left, we have the patients who were admitted using an elective procedure. So these patients tended to be older. The median for the elective patients is about 70 compared to the median for the emergency patients. Looks like that's closer to 65. They tend to be a little less varied. The box is narrower. The size of that box represents the middle 50% of the patients. So they tend to be more clustered in that older age compared to the emergency patients tending to be more spread out. There are two elective observations that are outliers, so who are younger than the rest, a little bit surprisingly younger. Compared to emergency, there really aren't any outliers. The last type of plot that I want to talk about in this video and how to interpret are scatter plots. So what do scatter plots show us? Well, we have a look at the relationship between numerical variables with these. So we've got an x variable, a y variable. We plot the x on the x-axis, the y on the y-axis. Each dot represents an observation, so an xy pair. When we're looking at these scatter plots, here are the things we might want to look for. We might say that two variables have a positive association if there's an upward trend. So as x is increasing, y is also tending to increase. We might say that two variables have a negative association if there's a downward trend. So as x increases, y tends to decrease. Now, do you think there's going to be a relationship between some variables? So let's look at patient age and heart rate first. We've got two numerical variables, so we'll use a scatter plot here. This is a really good example of what you'll see if there isn't a relationship. So we have heart rate on the x-axis, age on the y-axis. The points are fairly scattered, no clear trend, no clear relationship. What about systolic blood pressure and heart rate? Again, try to make a prediction. They're more concentrated together. I will give the plot that, but there's still no clear relationship. There isn't much of a link between heart rate and systolic blood pressure. Now, sometimes it can be easier to look for those links or those relationships between variables can become more apparent if we start splitting our data up into smaller groups. So maybe there's a relationship between heart rate and blood pressure, depending on whether or not the patient was admitted under emergency or an elective planned procedure. These blue lines here represent linear trends. So if I dropped a line into my data, what would I see? So we have elective patients on the left, emergency patients on the right. They're still fairly scattered, but there are some differences. On the left with the elective patients, as the patient heart rate goes up, the systolic blood pressure tends to increase, although very slightly. For emergency patients, that relationship is less apparent. The slope of that linear trend line is less strong. Okay, so it is time to take another break. In the next and final video in this Lecture 4 series, we will talk about calculating some summary statistics. See you soon.